Good day everyone. This is Engineer Royce Formaliza and welcome po sa ating Principles of Communications. Okay, last time we discussed about the fundamentals ng electronic communications and we discussed as well yung mga units na gagamitin natin and of course the gain, di ba? The decibel gain and yung noise also. Now, today we will be discussing about the fundamentals of amplitude modulation. Okay? Sabi natin dati that one of the barriers of communication is the distance between the sender and the receiver. Let's take, for example, voice communication. Merong dalawang tao, diba, nag-uusap. Kapag sila ay magkalapit, they would use their normal talking voice, diba? But as the distance between these two people increases, the transmitting of the information, yung voice, medyo nagiging mahirap. Bakit? Kasi may mga sumasama ng noise and dahil lumalayo yung receiver and yung transmitter sa isa't isa, yung normal na speaking voice ay nag-fade out. Tama? Okay. Now, what will the speaker do usually is to raise the volume of his voice para mas marinig nung receiver na medyo malayo na sa kanya. But if we're going to increase the distance between them further, it will be impossible to hear yung speaker. Diba? Now, what we will normally do is we're gonna employ a sound system, microphone, amplifier, speaker, para mas lalo pang mapalakas yung power or yung level ng voice ng speaker. But if we will be increasing the distance between the two more, so what will happen? Kahit gaano kalakas nung sound system, hindi na yan maririnig nung receiver natin. And then, we also discussed about the idea of what if instead of transmitting the raw information, sa example natin, the raw information is the voice, what if instead of transmitting it directly, why don't we use another signal na sasakyan nung ating information, nung raw information natin? Sasakyan niya yon papunta dun sa receiver. Okay, then pagdating dun sa receiver, ang gagawin ni receiver, kukunin niya lang, i-extract niya lang yung information galing dun sa composite signal. And we call this process modulation process. Technically, modulation is the impressing of a modulating signal onto the carrier. And one of the types of modulation is, of course, our amplitude modulation. Here in modulation, usually the lower frequency signal is our information. Our information may be in different forms. It can be an analog signal in the form of voice. It can be a digital data. Okay? Regardless of whatever form it is, as long as this modifies a higher frequency signal, which is our carrier, this is already modulation. Okay? And the modulation, the byproduct of the modulation, usually alters a certain parameter of our carrier. Saan ba siya sumakay sa carrier natin? Diba? Parang tayo lang din. Pagka sasakay ka, saan ka ba sumakay sa sasakyan? Ikaw ba yung nasa passenger seat? Ikaw ba yung nasa back seat? Diba? Or nakatapload ka ba? So, alin yon? If our modulating signal sumakay siya sa amplitude ng carrier, meaning the modulating signal is modifying the amplitude of our carrier, then it is called amplitude modulation. Now, there are merong iba't ibang parameters yung ating carrier bukod sa amplitude. So, nandyan yung frequency, nandyan yung phase. So, iba't ibang types din yun ng ating modulation. Okay? This is our amplitude modulation. As you can see here, this trace on the right, itong kulay red, this is our composite signal or composite waveform. This is an AM wave. Okay, simula dito. Yan, simula dito. So that's our AM wave. Dito sa taas, you will see na trinace natin yung mga positive peaks. And sa baba, mapapansin nyo, meron din tayong imaginary line, trinace natin yung negative peaks. This is what we call the envelope. Para saan yung envelope? Envelope actually is the exact shape of our modulating signal. From our definition kanina, modulating frequency modifies the amplitude of our carrier. Ito yung ating carrier. Ayan. Pagdating dito, nung ininjectan siya ng modulating signal, napapansin nyo yung amplitude ng ating carrier. Nagbavari na siya, di ba? Hindi na siya ito. Hindi na ito yung amplitude niya. Why? Because the modulating frequency modifies the amplitude parameter of our carrier. And pagka ginawa niya yon, it forms an envelope if we're gonna trace the positive peaks and if we're gonna trace the negative peaks. And it says that this envelope is the exact shape of the modulating signal. But there's a limit, no, na kailangan nating tandaan. The overall amplitude or the peak amplitude of our modulating frequency should be less than the peak amplitude of our carrier. Actually, it can also be equal, less than or equal. Bakit? Kasi if masyadong mataas or mas mataas si VM compared kay VC, ang mangyayari, itong valley ng ating envelope will cross the zero line. And ito naman sa baba, itong envelope na to, itong peak niya will cross the zero line. Ang mangyayari, magmi-meet itong dalawang envelope. Pag nag-meet yan, magka-cancel out, hindi na natin makukuha yung exact shape ng modulating signal. But we're gonna discuss about that later. Okay, so this is amplitude modulation. To achieve amplitude modulation, we have a modulator circuit. So what this ang ginagawa ng modulator is it combines the signal, the information signal, and the carrier signal, and then imimix niya yon, i-output niya as an AM waveform. So that's what a modulator do. Example here is meron tayo, ito simple lang siya na sinusoidal waveform. Our modulating signal, so Vm sine 2 pi ft, and our carrier signal, Vc sine 2 pi fct. So pagka yan pumasok sa modulator natin, ang output niyan is our AM wave na. It's a composite signal. Ito na po siya. Vc sine 2 pi fct plus Vm sine 2 pi fmt times sine 2 pi fct. Okay, so ito na yung AM wave natin in equation. Another example is ito. You can also look at it in the time domain. So this red trace is our modulating signal. And we have our carrier signal. Okay, our carrier signal, by the way, is constant frequency, constant amplitude high-frequency signal. So, yan. Mapapansin nyo, ito ay isang frequency lang yan. Yung amplitude niya is constant. Okay? And definitely, mas mataas ang frequency nito compared sa modulating signal. Now, if we're going to insert this 2 sa ating modulator, ganito po yung output niya. Itong kulay blue na trace. So, as you can see, the modulating signal is varying the amplitude of our carrier signal. As a result, if we are going to trace the positive peaks and the negative peaks, we're gonna see the exact shape of our modulating signal. Okay? So, yun. That is our modulator. That is the circuit na responsible for making an AM wave. Now, if we don't want to have a distorted amplitude modulated wave, we already said that VM should be less than or equal to VC. It cannot be the other way around, na mas malaki si VM compared kay VC. Okay? Because if we do this, there will be an over-modulation. Now, this very simple relationship between VM and VC will form an equation. Okay? And we term this as the modulation index. This will tell us automatically, by just the figure of this modulation index, it will tell us how good our system is in terms of modulation. Modulation index, by the way, is also called in other books as modulation factor, modulation coefficient, minsan degree of modulation. And if we express it in percentage, it will be called percentage of modulation. This is simply the ratio of the peak modulating voltage to the peak carrier voltage. So that is VM over VC. This is our modulation index. Okay? Percentage of modulation, or the modulation index then, we can also derive this from our modulated wave, from our complex waveform. Yung slide natin kanina, this is being derived from the peak value ng VM and VC. But there are times that the peak value of the modulating signal and the carrier signal is not being said. So, what if ang available lang sa atin is our AM wave, yung modulated wave na? So, pwede pa rin po natin ma-derive yung modulation index with this relationship that is stated here. The peak modulating voltage, that is equal to Vmax minus Vmin over 2. Vmax is the maximum value of the modulated wave. Vmin is ito, papunta sa 0. So that is the minimum voltage of our modulated wave. VC naman, on the other hand, is Vmax plus Vmin over 2. So if we're going to use this and substitute it dun sa ating equation, di ba? Ang M natin is Vm over Vc, and Vm is Vmax minus Vmin over 2. So ito siya sa taas. Divided by Vc, ito yon, Vmax plus Vmin over 2. So we will be getting this equation. The modulation index pala is simply Vmax minus Vmin over Vmax plus Vmin. Okay, so tandaan po natin yan. And from there, if you multiply that by 100, then it will be ilan? It will be the percentage of modulation. This is what happens kapag Vm is greater than Vc. Of course, if Vm is greater than Vc, it is obvious that the modulation index will be greater than 1. Sabi nga, it should be less than or equal to 1. You can see here on the top part of the graph, you will see this is an AM wave at 50% modulation. So mapapansin mo, yung minimum voltages sa positive alternation and negative alternation ay hindi nagtatouch. So this is 50% modulation. Ibig sabihin, M is 0.5. What happens if M is 1? Meaning, Vm is equal to Vc. Kasi kailan magiging 1 ng M? Pagka ang Vm at Vc ay equal. So, ang mangyari niyan, magkakaroon ng kissing pattern. So, ito, yung peak net, yung minimum nito, tsaka yung ito, magdidikit yan sa 0. Now, as you can see here, wala pa ring distortion na nangyari. So, yung positive peaks is still the shape of the modulating signal, and yung negative peaks is still the same of the modulating signal. But what will happen if our modulation exceeds 100%? In this example, it is 150% modulation. So, mapapansin nyo, yung envelope natin, nagsiswing na siya, nag-overlap na yung envelope. So, anong mangyayari dito? Ang makikita natin sa trace ay ito. Hindi na natin makikita itong trace na to. Hindi na natin yan makikita. Ang makikita natin sa trace ay ito na po. After niya dito, hindi na yan tutuloy sa baba kasi may makikita siya dito. Ayan. Tapos balik ulit siya. So this is no longer the shape of our modulating signal. Now this is over modulation. And as a rule of thumb, we don't do this in our amplitude modulation. Okay? So I hope that is clear. Next, we also have what we call sidebands. Ano naman yung sidebands? It is part of the modulating process na ginawa natin that there will be sideband frequencies. It will be created. And the frequency spectrum, ito, as you can see here, we can see that the sidebands are spaced at a certain distance from the carrier frequency. Actually, they are spaced in one modulating frequency below and above the carrier. This is carrier po, carrier frequency. So if we know our FC, ito siya, and we know our modulating signal, let's say it has a frequency of F sub M, then we can easily get our carrier or our sidebands. We can easily say that the upper sideband is the carrier frequency plus the modulating frequency, and our lower sideband is the carrier frequency minus the modulating frequency. Okay? Now, eto naman siya pagka tinignan natin siya sa equation. On top, this is yung equation na pinakita ko kanina. Ito yung output ng ating modulator. It is Vc sin 2 pi fct plus Vm sin 2 pi fmt times sin 2 pi fct. Using our trigonometric identity, sin A sin B, that is actually equal to cosine A minus B over 2 minus cosine A plus B over 2. So what we're looking at is itong dalawang sign na to. We have sin A and sin B. So that will be, so ito retain to, Vc sin 2 pi fct plus cosine A minus B, diba? So ito ang A niya, ito yung B. So that would be plus Vm over 2 cosine 2 pi fc minus fmt minus Vm over 2 cosine 2 pi fc plus fm of t. Now, ito na yung pagka-dinistribute natin tong equation na to. Now, bakit ko ginawang ganito yung equation? Because from this equation, we can clearly see that the AM wave or the modulated wave has merong tatlong signal. First is the carrier, second is the lower sideband, and third is the upper sideband. So ito pala ay sum netong ng tatlong frequencies na to. Now, paano ko nasabing ito si lower sideband? Kasi FC minus FM siya. So yung frequency niya mas mababa sa FC. So this will be the lower sideband. Ito naman, paano ko nasabing upper sideband? Because yung frequency niya ay FC plus FM. Meaning, mas mataas yung frequency niya sa carrier. So this will be the upper sideband. Okay? In time domain graph, you can see it here. Ito na sa letter A, yung kulay pula. This is our information. And you can see here, B, C, and D. Ito po yung tatlong yon. B is the lower sideband. You will see here that if you're going to look closely, you will see that the frequency of this is lower compared sa carrier and sa upper frequency. C is the carrier and D is the upper sideband. Okay, if we're going to combine this, if we're going to add this, it will produce the sum of ito. Yung solid po na kulay blue. Hindi yung broken line because that's the envelope. Itong solid line na kulay blue sa letter E, that is our composite AM wave. Okay, now why is it important that we also know about the sidebands? We will discuss it later. Okay, here in this graph, you can see here, this is in frequency domain and time domain. Okay, kung dito ka nakatingin, so oscilloscope gamit natin. Kung dito ka naman nakatingin, spectrum analyzer yung gamit natin. Kung sa oscilloscope tayo tumitingin, we will see ito ang makikita natin. Pero kung hihimayin natin tong AM wave na to, actually ang nakikita natin ay isa, dalawa, tatlo. Combined. If we are looking at a spectrum analyzer in the frequency domain, we won't see this waveform. What we will see is tatlong nag-peak. Kasi dito tinitingnan natin saang frequency siya. So mapapansin nyo, nandito si FC. Ito si lower sideband, FC minus FM. And ito si upper sideband, FC plus FM. If we will put this in a graph, it will look like this. Ito si FC. So in this example, it is at 2,800 kilohertz. And then, ang modulating frequency kasi dito, sa example niya ay 3 kilohertz. So, ang gagawin lang natin dyan to get the frequency of the upper sideband, we're just gonna add the modulating frequency. So, add tayo ng 3 kilohertz, then it will be at 2,803 kilohertz. The lower sideband is at 28 minus 3. So, it will be at 2797 kilohertz. Okay. Now, this is actually, it varies from case to case. So, naglagay lang siya dito ng guard band. Okay, but technically, the bandwidth here would be from 2797 to 2803. Or the bandwidth is actually twice the modulating frequency. So, it will be 6 kilohertz. Or pwede mo din gamitin, bandwidth is frequency of the upper sideband minus frequency of the lower sideband. So 2803 minus 2797, that is still 6 kilohertz. with the center frequency at 28 kilohertz. Okay? So, sana malinaw. Now, let's move dito. The power in AM. Ito yung frequency natin. Ito yung equation ng AM wave natin. So, we already established that the AM wave is divided into three, or a summation of the three waveforms: the carrier, the the lower sideband, and the upper sideband. So carrier, lower sideband, and upper sideband. But as you can see, yung information natin is contained lang dito. This is simply the carrier lang. It's the same doon sa pinaka-start. Diba? This is the equation of the carrier. Our information is contained here. Ayan. But if we're gonna look at the power formula for an AM, we will see that the power of the sidebands is only a portion of the power of the carrier. Diba, ang maximum M natin or modulation index natin is 1. So therefore, the maximum power pala of one of the sidebands is only 1/4 of the carrier power, or 25% of the carrier power. If the carrier is, let's say, 100, then ang sideband power ko pala ay 25 watts lang for the lower sideband and 25 watts for the upper sideband. And hindi ba sayang yun? The very reason why we use modulation is to transmit the information and to use most of the power available for us para sa carrier na wala naman doon yung ating information. Now it will seem to be a waste of energy. Tama? So, but that is the case nung modulator natin. Pero may mga paraan to conserve our power. Okay? Now, this is the general equation. Total power is PC plus M squared over 4 PC plus M squared over 4 PC. So, pareho lang po ang power ng upper and lower sideband. If we combine them, ito na yung pinaka-equation natin. So, huwag niyo pong kalimutan ito. So, the total power is PC times quantity 1 plus M squared over 2. From here, makukuha na rin natin yung formula for current and formula for voltage. So, we just have to substitute it. Di ba yung power natin is I squared R and V squared over R. So, papalitan mo lang yan. Then we're gonna get our equations. So, if we're gonna get our, for the current, that would be I T squared R is equal to IC squared R times 1 plus M squared over 2. So, makakancel lang yung R nyan. So, square root natin to. Nagahang lang yung pen tool ko. So, IT is IC times square root of 1 plus M squared over 2. Same process din po pagka kukunin natin voltage. The total voltage of the AM wave is VC times square root of 1 plus M squared over 2. So now, you have 3 equations. But you don't have to memorize all 3 equations. Itong power lang, and then, i-derive mo na lang itong dalawang equation na to. Okay? So, again, most of our power is being wasted on the carrier. Now, to overcome this waste, as engineer, we want our system to be efficient and economic at the same time. So, we modified our AM. So, dahil hindi naman natin kailangan yung carrier, or rather, yung information wala naman sa carrier, then pwede naman nating i-suppress yung carrier before natin i-transmit para hindi na masasayang yung power natin. If we're gonna suppress the carrier, then it will leave us with 2 sidebands. So, ito na lang siya. Ito sa time domain. So, mawawala na yung carrier, 2 sidebands na lang. In time domain, it will look like this. Itong kulay pula. And the envelope ito. Ayan. Okay? Now, if we suppress the carrier, we are going to call it yung ating AM as a double sideband suppressed carrier AM signal, or DSB-SC. Of course, the benefit of this will be no power will be wasted on the carrier. Okay? But, may isa na naman, no? Di ba kanina, yung information natin nasa sidebands. Pero, yung information kasi na nasa upper sideband is also the same information na nasa lower sideband. So technically, if we are going to transmit with a double sideband suppressed carrier, we are transmitting an information. Parang double send. Diba? So isang padala, dalawa ang laman. So dahil pareho lang naman ang laman nun, why not remove one para lalo pa tayo maka-save ng power. Tama? Now we can suppress again another carrier. It doesn't matter which one. You can suppress the lower sideband, you can suppress the upper sideband. It's okay. Kasi pareho lang naman yung information na laman yan. Now we're going to term this as single sideband suppressed carrier, AM signal. This is an SSB-SC. And ang power nito ay ine-express na in terms of PEP. Peak envelope power. And it's easy to compute for the peak envelope power, that is VRMS squared over the load, R. Okay, so this is our SSB-SC. The problem naman with SSB-SC is mas mahirap i-demodulate yung signal pagdating sa receiver side. Bakit? We will be discussing this naman pagdating natin sa receivers na lecture. But to give you a glimpse of how hard is it to demodulate signal without the carrier is para kasi makapag-demodulate tayo, para makapag-demodulate or ma-receive natin, ma-decode natin yung AM wave sa receiver side, isa sa requirement is to have the carrier. Now, if we're going to suppress the carrier pagdating sa receiver side, what carrier are we gonna use? Diba? Now, pwede naman sabihin, sir, inform na lang natin si receiver of what carrier will be used. But the next problem here will be the phasing. Let's say, in the transmitter, we used a 1 megahertz carrier. A carrier with 1 megahertz frequency. And in the receiver naman, we used, or we reproduced, diba? A carrier with 1 megahertz frequency na din. Now, is it safe to say na mas madali na siyang i-demodulate? Hindi pa rin. Bakit? Kasi ang susunod na magiging problem naman natin doon is the phase ng ating signal. Yes, madidemodulate siya, but we will be using a complicated circuit. So may mga additional circuit tayong gagamitin. And if that's the scenario, then of course the cost will also be higher. Okay, so that's the pros and cons. Ang pro naman ng modified na amplitude modulated signal is that konti lang yung power na gagamitan natin. Ang cons niya naman is mas mahirap siyang i-demodulate. Okay? So, yun. Now, these are the classifications of radio emissions. I don't know if you have heard of this, but there are codes for that. If it's a 3-letter code, usually. Halimbawa, I have an A3E. Ano ito? So, titingnan natin yan. Itong signal na to ay amplitude modulated. Then, pagdating dito, 3. Gumamit siya ng analog signal. Tapos, E. A3E pala ay voice. So, ito pala ginagamit to communicate using voice. Okay? So, yun. Pwede din yan merong subscript, double sideband, full carrier, o pag walang subscript. So, ito pala, TSB, full carrier. Double sideband, full carrier. O, paano kung gusto ko double sideband, no carrier? So, maglalagay ako ng subscript dito. A, subscript B, 3E. Yan yung code niya. Okay? So, yun. Medyo, ito, hindi naman to lahat ginagamit or hindi nyo naman to kailangan sauluhin. I just showed you that there is a code for these radio emissions. So, meron din yan, F3E. Meron yan yung J3E. Ayan. Single sideband analog voice. Okay, so may mga ganun po. Okay? So, ayun, that is the fundamentals of amplitude modulation. Okay, so next sa next lecture natin, i-discuss ko naman sa inyo yung ating mga modulator circuits. Okay, and of course, yung ating demodulator na side. Okay, so thank you for watching and have a good day.